Hello friends, in this video we will learn about the cycle detection algorithm. So let us say we have a linked list with the following nodes. So in the figure on the left side of the screen you see there are 5 nodes, 5, 6, 7, 8, 9. Now instead of the last node pointing to the null pointer, it is forming a cycle. So this part is forming a cycle, and we would like to detect this cycle in a linked list. So how can we do this? So there is a very famous algorithm. It's called the Floyd cycle detection algorithm, and this is a very efficient approach to solve such problems. So it works as follows. Let us say initially I have two pointers, a slow pointer and a fast pointer, and at every iteration, so let us first draw the linked list again. So I have the following case. I have the 5 nodes, and the last node is connected to node 7. Now initially I have a slow pointer and a fast pointer. Now as I traverse through the list, at every iteration the slow pointer is incremented by 1. So the slow pointer is incremented by 1 and the fast pointer is incremented by 2. And at any point, if the slow pointer and the fast pointer point to the same node, then we can say that there is a cycle. We have detected a cycle in a linked list. So let us see a step-by-step process how this works. So initially the slow pointer is incremented by 1. So what is going to happen in the first iteration is as follows. So this is the first iteration. So I have 5, 6, 7, 8, 9, and in the first iteration the slow pointer is going to be pointing to the node with value 6, and the fast pointer is going to be pointing to the node with value 7. So this is the slow, this is the first, and this is of course connected to this node. So this is the case in the first iteration. Now in the second iteration, what is going to happen is follows. So I have this, and now the slow pointer is going to be pointing to the node with value 7. So this is my slow, and the fast pointer, so this is the fast pointer will point to the node with value 9. So this is in my second iteration. Now let us continue the next iteration. So in the next iteration, so let us first draw the linked list again. So I have 5, 6, 7, 8, 9. This is connected to 7. So in the next iteration, the slow pointer is going to be pointing to this node, and the fast pointer, since it's incremented by 2, will also point to this node. So if such a scenario arises where both the slow and the fast pointer are pointing to the same node, we can say that there is a cycle in a linked list, and we have successfully detected this cycle. And so we just took 3 iterations to find this. So let us see how we can implement this in Python. So in the last tutorial on linked list, I showed you how you can construct a linked list and perform some common operations like traversal, insertion, deletion. So we will be using the classes from that file and try to declare our linked list. So let us begin. So from the linked list file, and I will point the link to the linked list tutorial below. So let us begin. So from the linked list file, I can import my node class and my linked list class. Now I will initialize 5 nodes. So let us construct these 5 nodes, and the nodes will have the following values. So it's 5, 6, 7, 8, 9. So this is the first node. Then I have the second node, so 6. Then node 3 is 7, and so on. So node 4 has a value of 8, and node 5 has a value of 9. Now I will construct a linked list using these nodes. So I can initialize my linked list class, and I can call the following function. So I can do insert back node 1, then so this would be the first node, then I will insert back the second node, and so on. So let me connect all the nodes. So this is node 4 and insert back node 5. Now as you can see in the figure, to demonstrate this example, I will connect the last node, so this 9th node with the value 9 to the node with the value 7. So this is 1 2 3 4 5. So what I can do is I can do node 5 dot next is equal to node 3. So this will form a cycle in the linked list. So let us see how we can solve this. So as I explained in the first part of the video, we will initialize 2 pointers. So we have a slow pointer connected to the first node or the head node, and the fast pointer also connected to the first node. Now we will run a while loop. So we can do while there is a slow pointer and there is a fast pointer and there is a next of the fast pointer. So if this is the case, then what we can do is we will increment the slow pointer by 1. So we can do slow pointer is equal to slow pointer dot next. Then we will do fast pointer is equal to fast pointer dot next dot next. So we have incremented the fast pointer by 2. Now if the slow pointer is equal to the fast pointer, that is both of them are pointing to the same node, we can print that there is a cycle in a linked list, cycle in the list, and we will also print the node value where the two nodes are equal. So we can just print slow pointer dot data, and we can break out of the while loop because we don't want to continue anymore, because this proves that there is a cycle. Otherwise I will, for debugging purposes, I'm going to just print the slow pointer data value and the fast pointer data value. So now let us run this program. So I can execute my program out here. So I have Python Floyd cycle. So as you can see, I have in the first iteration the slow pointer is pointing to the node with value 6, so this one, and the fast pointer is pointing to the node with value 7, so this one. So this is slow and this is fast. Then in the second iteration it is pointing out here, so slow, and the fast pointer is pointing out here, so 7 and 9. And in the third iteration both are pointing to the node with value 8, so this one. And this concludes that we have found a cycle in the linked list. So I hope you like this video and stay tuned for many such videos. Thank you.